In previous videos, we learned that the following statements are equivalent. 7 is a factor of 91, 7 is a divisor of 91, 91 is divisible by 7. So all three of these contain the same basic mathematical information. Now we can add another statement to that list. 91 is a multiple of 7. That new statement contains exactly the same mathematical information that the previous statements contain. And this is also language you need to know for the test. Throughout this video, assume P, Q, and R are positive integers. If we are given that P is a multiple of R, this means I could multiply R by some positive number and the product would be P. In other words, R is a factor of P and a divisor of P. So there's always that relationship, that reciprocal relationship between multiples and factors. So 75 and 1250 are multiples of 5 precisely by the fact that 5 is a factor of both of those numbers. 63 and 888 are multiples of 3. With 63 it's easy to see. With 888 you could use the trick that we've discussed in the previous video on divisibility tricks. If we add up the digits, 8 plus 8 plus 8, we get 24. 24 is divisible by 3, therefore 888 must be divisible by 3. So some basic ideas. I'll go through several ideas related to multiples in this video. Just as 1 is a factor of every positive integer is a multiple of 1. Similarly, just as every positive integer is a factor of itself, every positive integer is a multiple of itself. Those are two primary ideas. Another idea. If we need, say, the first 5 multiples of a number, we simply multiply the original number by the numbers 1, 2, 3, 4, and 5. So suppose we needed the first 5 multiples of 12. So that would be 12 times 1, 2, 3, 4, and 5. We can also get those by repeatedly adding 12. 12 plus 12 is 24, plus 12 is 36, plus 12 is 48, and so forth. So that's very interesting. We can add or subtract 12 and get new multiples of 12. We can actually generalize that idea. So that is multiple idea number 3. If we know P is a multiple of R, then it must also be true that P minus R and P plus R are also multiples of R. So very interesting. Suppose we are told that 24 over 1 is a multiple of 7. Now there's no way you would be expected to know that. Here it's just being dumped in your lap, this particular mathematical fact. Okay, 24 over 1 happens to be a multiple of 7. If we know that, what else can we figure out? Well, we can generate a number of other multiples. For example, we can add 7 and get 2408, add 7 again, get 2415, add 7 again, get 2422. All of these have to be multiples of 7 as well. We could also subtract 7 from the original number. 2401 minus 7 is 2394. Subtract 7 again, we get 2387. Those also have to be multiples of 7. So we could add or subtract as many 7s as we wanted, and we would still get another multiple of 7. So we can create many more multiples just from this one multiple. Now this idea of adding or subtracting as many multiples of 7 as we want, that in fact implies we could add or subtract any multiple of 7. And in fact that's the next multiple idea. If P and Q are multiples of R, then P plus Q and P minus Q must also be multiples of R. Because if I can add 7 or any number of 7s, that also should mean I should be able to add any multiple of 7 or subtract any multiple of 7, and I would still have another multiple of 7. So we can add or subtract different multiples of R to get more multiples of R. That is a deep idea right there. So let's look at these two. Obviously 700 is a multiple of 7. Obviously 49 is a multiple of 7. We can generate other multiples of 7, and they must include 700 plus 49, which is 749. We could add 49 again, get 798. That has to be a multiple of 7. We could also subtract 700 minus 49, get 651. We could subtract 49 again, 602. All of those must be multiples of 7. Along these lines, notice the following. Since 52 is a multiple of 13, we could add 2 52s, or 3 52s, or any number of 52s. we could add 52s galore, and it would still be a multiple of 13. So in other words, no matter how many times we add 52, we could have any multiple of 52, and it would have to be a multiple of 13 as well. Therefore, we can generalize this rule. If P is a multiple of R, then any multiple of P is a multiple of R. That also is a very deep idea. Finally, to extend that, if P and Q are multiples of R, then of course the product of P times Q must also be a multiple of R. Well, that makes sense certainly, because any multiple of P and any multiple of Q is a multiple of R. For example, 24 and 80 are both multiples of 8. To get more multiples of 8, we could add them, we could subtract them, or we could multiply them. And all of those would give us more multiples of 8. Notice, though, we can't divide. If we divide 80 by 20, the quotient isn't even an integer. So it's certainly not going to be an integer divisible by 8. Here's a practice question. I recommend pausing the video and working on this question now. Okay, let's talk about this. K, K plus 200, K plus 350, and 15K are all multiples of P. Then P could be which of the following? Well, let's think about this. We know K is a multiple of P. So we know that any multiple of K is a multiple of P. So this 15K, this is useless. This doesn't help us at all. In other words, any integer times K is still going to be a multiple of P, so the 15 is completely useless. So that doesn't help us at all. That's a distractor. But these are very useful. And in particular, we could take the difference. We could subtract K from each one of these. Well, if we subtract K from this, we get 200. So 200 must be a multiple of P because it's the difference between two multiples. 350 must be a multiple of P because it's the difference between two multiples. Well, now I could do 350 minus 200. Of course, that's 150. That must be a multiple of P because it's the difference between two multiples. Well, now I could do 200 minus 150, and I get 50. This must be a multiple of P. Well, which numbers on this list could be factors of 50? And it turns out there's only one, answer choice B. In this video, we discuss multiples and their relationship to factors and divisors. It's very important to know these words, to recognize these words, because the test will use all these words and expect you to recognize their interrelationships. We talked about if P is a multiple of R, we can add or subtract R any number of times to get more multiples of R. If P and Q are multiples of R, then the sum, difference, or product will be other multiples of R, and any multiple of P or Q would be another multiple of R.